Okay, so question 5. The two given triangles are similar, right? So you've got two similar triangles, and all that means is they have the same angles. Okay, so 90 degrees, 90 degrees, an angle, an angle. This angle here is obviously going to be the same as this angle here, because if these two angles are the same, then this angle has to be the same, because angles in a triangle are up to 180 degrees. Okay, so we're dealing with similar triangles. Copy and complete the statement. Each side of the bigger triangle is so many times the length of the corresponding side of a smaller triangle, right? So basically they want to see how much we're scaling this up by, so how we turn this into this. And how we do that is we look at the values that we're given. So how do we turn 5 into 7.5? So 5 times something gives us 7.5. So 5 times something will give us 7.5, or 7.5. Okay, so in order to find out what that something is, what we need to do is we need to divide both sides by 5. So 7.5 divided by 5, okay, 7.5 divided by 5 will give us our answer, and we get the answer there of x is equal to, let's type that in, 7.5 divided by 5, and that gives us 1.5. So you can see there that everything is growing because I'm multiplying every side there by 1.5. So 5 multiplied by 1.5 gives us 7.5. So that's what maps these two together, yeah? Okay, we're looking for a value for x and y. So if I'm looking for a value for x, let's see how we can map them together. So 4, the multiplier there is going to be 1.5. So 4 multiplied by 1.5 will give us our x value. So that gives us 6. And if we want to find this value here, what maps these two together? It's going to be 1.5 times bigger. So 3 multiplied by 1.5 will give us 3 multiplied by 1.5, which gives us 4.5. Okay, so the value for y will be 4.5. Okay, so question 6. Question 6, explain why the triangle ABC and DEF are similar. Find the value of x and y. Okay, so the reason why they're similar is very obvious. Okay, because this angle and this angle are the same, this angle and this angle are the same, and this angle and this angle are the same. So if you've got three angles the same, then you've got similar triangles. Similar as all three angles are the same. So, and you should be aware, obviously, that similar shapes, if they've got the same angles, that's fine. But typically one's bigger than the other, or one's an enlargement of the other. So it's where you have a triangle and you've got one that's larger than the other, or one that's smaller than the other, but they have the exact same angles. Okay. Find the value of x and y, right? So we're looking for the value of x and y. Now, there's loads of different ways we can do this. We can find the multiplier to see what maps this onto this, or else we could write them as fractions. So I'll do both ways there so you can see, right? So let's just start. We'll find, first of all, we'll see what the scale factor is, or what the multiple is, right? So let's just look at 18 and 12. So 12 multiplied by something. So if I go this way, 12 multiplied by something will give me 18. So 12 multiplied by something will give me 18. So in order to find out what the multiple is, or what the scale factor is, what we typically call it in maths, find out what that is, I need to divide both sides there by 12. So 18 divided by 12, and 18 divided by 12 gives me an answer of 1.5. So I'm increasing everything there by 1.5. Okay, so if that's what mapped them together, I now need to see what will map these together. Well, I'll do x first because x is first in the alphabet. Okay, so the multiplier is 1.5. It's the exact same for this one. So I need to take my 14 and multiply it by 1.5. And 14 multiplied by 1.5, so 1.5 times 14 gives me 21. I need to do the same here for the x value and how that maps onto the y value. So I know the multiplier is 1.5, so I can take 10 and I can multiply it by 1.5. And 1.5 times 10 will leave me with 15. Okay? So if we're going to do this as fractions, what we do is we take two corresponding sides. So I'm going to take these sides first, right? So the 18 there and 12 both map onto each other. So I can say 18 over 12 is equal to, and if I'm trying to find the value for x, I can say x over 14. So x over 14. Just be very, very careful. If the 18 comes first, then the 12 has to come first, or it has to be the numerator. So if the 18 is the numerator in my fraction, then the 12 has to be the numerator in the corresponding fraction. Okay? If I do things this way, I've got two fractions equal each other. If I've got two fractions equal each other, I always cross multiply. And if I cross multiply there, I'll get 12 times x. Okay, so 12 times x, which is 12x, equals 18 times 14. So 12x will be equal to 18 multiplied by 14 gives us 252. So to find out what x is, I divide both sides by 12. So divide that by 12 and we get 21, which is what we calculated in the last question. Okay. So that's the first one done. I'll try and find, well, I'll get y there as well. So let's just look at y. So I need to form an equation. So I need to form an equation to find y. So I start off with what I know. I know that 18 and 12 are together, so I'm going to put them together again. So 18 all over 12 is all equal to, and I'm going to get my y values there. Okay, so I'm going to put my y values in there. So the 18 maps onto 12. Okay, the same way that y maps onto 10. So I can put y over 10. Okay, I've got two fractions equals each other. So what I'm going to do now is I'm going to cross multiply. So 12y will be equal to 18 times 10. So 12y will be equal to 180. So y will be equal to 180 divided by 12, which gives us 15. So that's just a second way to use find values with similar triangles. If you like using the multiplier, use the multiplier. If you like doing it by mapping corresponding sides, map corresponding sides. It's all the same thing, right?